Now that we've defined the p-value or probability, let's take a look at how we decide when that probability is small enough that we're going to reject the null hypothesis. So the way that we do that is we compare that to a significance level known as alpha. So typically, those range from 1, 5, or 10%, and researchers set that significance level alpha based on the type of research. So if it's something that's not life or death, like the proportion of students who like Hawaiian pizza, we might choose a larger significance level, like 10%, because it's not life or death if we get the wrong answer here. If it's something like the bolts that hold the wings on an airplane, where that is a life or death situation, we want to make absolutely sure that we're making the right call here. And so we'll choose a much smaller significance level, like a 1%, meaning that probability has to be less than 1% that those are going to fail in order for us to accept that these bolts are actually really going to work on this airplane. So our typical levels are a 1, 5, and 10%. And if no significance level is given, we use our alpha equal to 0.05 or 5%. All right, so when we compare our p-values and our significance level, there's two possible outcomes. Case 1, we get a probability or p-value that's smaller than or equal to alpha. In case 2, that probability is bigger than alpha. So let's start with case 1. Our probability or our p-value is as small or smaller than alpha. When that happens, we say our results or our data are statistically significant at that level of alpha. In other words, the alternative hypothesis is more likely and we reject the null hypothesis. Okay, so we're going to keep looking at case 1 and then we'll come back to this slide and revisit case 2. So still in case 1, so p is smaller than or equal to alpha. Our decision here is that we do reject the null hypothesis. Our conclusion is that we think that the alternative hypothesis is more likely. So our results are statistically significant at that alpha level. We would say it if this was a jury trial that our person was guilty. So we think that that alternative hypothesis is more believable. Okay, and so we have that picture of the normal distribution here. And notice that it is centered at the null hypothesis. So H0 is equal to mu. And then we have an alpha level, and then you'll see that the p-value is smaller. It's further out in the tail. So the further you are out in the tail, the smaller your probability or p-value, and the more evidence we have against that null hypothesis, meaning that we do reject. All right, so let's look at case 2. I'll go back to this other slide. So case 2, that p-value or probability is bigger than alpha. So if that's the case, we say our results or our data are not statistically significant at that alpha level, and we do not have enough evidence to reject the null hypothesis. Okay, so we're never going to say that we accept the null hypothesis. Our only options are we do reject it or we do not reject it. So if our p is bigger, then we do not reject the null hypothesis. So that's our decision, do not reject. The conclusion is that the alternative hypothesis is not more likely. Okay? So our results are not statistically significant at that alpha level, and our jury trial result is not guilty. So our result is always talking about the alternative hypothesis. So we're never going to prove that the null hypothesis is true. That's not how these are set up. We're always going to be referring to the alternative hypothesis in our conclusion. So either guilty or not guilty. And if we look at the picture here, we're still centered on the null hypothesis, but now you see that the sample mean X bar is much closer to the null hypothesis. So our p-value is bigger than that alpha. So the closer our sample mean is to the population mean or to our null hypothesis, we're going to get a larger probability of p-value when we have less evidence against the null hypothesis. Okay, so once we've made that decision to either reject or not reject, then we're ready to write our conclusion statement. So remember that if p is smaller than alpha, we're going to say guilty. We believe that that alternative hypothesis is more likely. And so we're going to fill in that sentence. We'll put in our p-value and our significance level. And so since we do reject the null hypothesis, we do have evidence that the mean of whatever we're looking at is following the alternative hypothesis. And vice versa, if our probability is bigger than alpha, we have do not reject. So we have not guilty. So we'd fill in our p-value and significance level, and we'd say we do not have evidence about the mean and the alternative hypothesis. So when we say do reject, we do have evidence about the alternative hypothesis. If we have a p that's bigger than alpha, we do not reject and we do not have evidence. All right, we're going to go over this slide again in the next video, and then we'll actually do some examples.